Hi, welcome to this GCSE prediction for the Paper 3 higher tier Edexcel Maths paper. Enjoy! Hi, I'm Chris Gilpin and welcome to this prediction for the Paper 3 Maths paper. I hope Paper 1 and 2 have gone well for you. And I'm not going to talk too much, but don't forget that these papers are on our website on maths.com, which I'm sure the link will come up there now. If you click on the link, it will take you to the prediction on our website. Don't forget that the prediction on our website changes the numbers in the questions, so you can do it as many times as you want, and you're not just getting the same answers each time. This video will go through all of the answers to a set of numbers. So if you don't understand a question, come to this video and you can see how to do it for maybe a different set of numbers, but you can get the methods. If you check out our website, we've got tutorials for everything. We've got topic busters, demon questions, practice papers, all sorts of things. So please check out our website on maths.com. If you enjoy this video, please click like. If you want to see any other stuff from us, especially over the next few days, please click subscribe. Thank you and enjoy the video. At first glance, this seems like a really easy question. It seems like the answer will just be 80. But we've got to understand the way that bearings are written out. It says work out the bearing of A from B. It means that we are at B and we're trying to find where A is in relation to B. So the actual question is asking you for this angle here. Now don't forget, bearings are the angle going clockwise from north. So not so easy. The first step of doing this, and there are different ways of doing this, is just draw a line. In fact, I'm going to use my straight line one. Just draw a line straight down at B. If I can get it right, there we go. Now, north lines are always going to be parallel, and we can use that to work out this angle here. This angle here will be the same as this angle here because they're Z angles or alternate angles. So that's also going to be 80. We know this one is a straight line, so we know this is going to be 180 degrees. So all we need to do to work out the bearing is do 180 plus 80, and when you add them together you get 260. So the bearing is going to be 260. Now there are other ways of doing it. You could have worked out this angle, because this angle and the 80 degrees over here are co-interior, interior or allied angles, whichever one you want to call them, so they will add up to 180. So we know that one's going to be 100, and then what we could have done is 360 take away 100, because it's the full circle is going to be 360 and we don't want that 100 one. You'd also get 260. Okay, so we've got a scatter graph question, and the first question asks us just to plot the information from the table into the scatter graph. So we've got ice cream sales at the top and temperature at the bottom, which is not kind of the same way around as on the graph, so we've just got to be careful. So the ice cream sales are 46, which is here on the scale, and the temperature is 31, which is here on the scale. And just check that you're looking at the scale correctly. So we're looking about, let's have a look, about here. Okay, next one, ice cream sales 40, which is here on the scale, and temperature 34, which is here. So we've just got to be careful, and it's about there. So those are the two plots that we want to take. Next question says, on another day had an average temperature of 45 degrees. Use the scatter graph to estimate the sales of the day. Now, you need to get used to just drawing a line of best fit to any scatter graph that you come across. You will have to do it, okay? So just do it. Just, even if it doesn't ask you to, just draw a line of best fit. Now, a line of best fit is just a line that follows all the data like that. You should have roughly the same amount of data top and bottom, but it doesn't matter if it's not perfect, okay? So let's have a look. So we've got average temperature of 45 degrees. So we're going to draw a line up from 45 degrees, which is about there. And we're going to draw, oh, the line didn't come up. So let's draw that line there. It's refusing to come up for some reason. Let's try another one. There we go. Let's try another line. Okay, let's do it the old-fashioned way. Okay, and then we draw a line across from where it's the line of best fit. Now, to me, that looks like about 55. But if you had the same question and you came up with a different answer of 54 or 58, it still can be correct because you might have drawn a slightly different line of best fit. Okay, so don't worry if you sit down next to someone, do the same question and get a slightly different answer. Just draw the lines, straight lines, unlike mine, onto your diagram to show the examiner that you worked it out. So we've got 55 sales we're predicting. Now, what do we notice about this? Well, look at where all the data is. All the data is here, and yet we're estimating outside the range of the data. Okay, it's called extrapolation, where you do that. So the problem with that, if you imagine we do a graph of height against age, so we have age at the bottom and height up the side, then when you're very young, you grow quite quickly. And if someone extrapolated your data and said, oh, okay, well that growth is going to continue, when you're 80 years old, you're going to be 20 foot high. Well, that doesn't make much sense. It's because we're quite confident with down here because we've got data for that, but we're not very confident with this bit here. We don't know whether the trend continues. Now with ice cream sales, if it's ridiculously hot, no one's going to leave their house. They're all going to be sitting inside with their air conditioning or sitting in their car with their air conditioning. So we know it probably won't continue. So if you just say that the estimate is outside the range of the data, and if you want to really impress the examiner, then you can use the word extrapolated. It's been extrapolated. These questions are just based on a few rules of indices. The first rule says that if you've got two powers with the same base, which these two do because they're both a, you add the powers. Now if you think about it, a squared is a times a to the power of 6 is a times a times a times a times a times a. So in total we're timesing a by itself 8 times. So it's a to the power of 8. The next rule says if you've got a power inside the bracket and outside the bracket, you times them together. So it's m to the power of 3 times 6, which is m to the power of 18. Now this last one's a little bit more complicated, and I'm going to write it out so I've got a bit of a larger one to play with. Okay, first thing I focus on is the number. Now 55 over 11, so I know that 55 divided by 11 is going to be 5. 55 divided by 11, that's all we've got to do. And the reason we can do that is there's only one term at the top and one term at the bottom. A term is defined by, whether there's a plus or a minus, and there's no pluses or minuses here. Okay, so next one, we've got the r's that we want to divide. So we've got r at the top and an r at the bottom. Now this r at the top is technically r to the power of 1. Now when we do r to the power of 1 divided by r to the power of 8, which I'm going to write out down here so I can show you, you take away the powers. So when you times them, you add the powers. When you divide, you take away the powers. So that's r to the power of minus 7. Okay, now we're left with the s's. And it's the same thing with the s's. This time we're doing s to the power of 15 divided by s to the power of 8. So it's going to be s to the power of 15 take away 8, which is 7. So my answer would be 5 r to the power of minus 7 s to the power of 7. Now a lot of people look at the word estimate and think, oh, let's just take a guess at it. The reason we're estimating is because of the first step that we have to do to answer this question. It doesn't mean that just have a quick punt and guess at it. With this question you won't be able to guess it correctly, or it'd be very, very unlikely. So we approach this the same as if it wasn't a group. However, we do have a group, so we've got to do a step first. This means that we've got a value somewhere between 0 and 4, including 4 but not including 0. Now the problem is that the first step in this method is to multiply these two numbers together, but you can't times somewhere between 0 and 4 by 14. So what we need to do first is find the midpoint. The reason we pick the midpoint is it's a good number to use to represent that group. If we assumed all those numbers were 0, then it would probably be ridiculously small. If we assume they were all 4, again it would be too high. So we assume that all those are 2 because it's right in the middle of the group, and chances are that most of them are closer to 2 than 0 or 4. So we find the midpoint of each of the groups, and the way of doing this is just adding the lowest and highest value together and dividing it by 2. Or just having a look. 4 to 8 will be 6, 8 to 12 halfway would be 10, 12 to 16 halfway would be 14, and 16 to 20 halfway would be 18. Then what we do is we get the frequencies and times them by the midpoints. So it's the same as if it wasn't a group now. So we do 14 times 2, which is 28, 6 times 6 is 36, 3 times 10 is 30, and then you can use a calculator for this, so 9 times 14, have an idea of what it's going to be. Hopefully it's 126, which it is, good. And 2 times 18, which is 36. And this is I call this the fx, although in this case we are calling the first one s, so it's the fs column. And then we need to find the sum of the fs column. So we're going to add up 28, 36, 30, 126 and 36 on the calculator, which is 256. And then we're going to sum up the frequencies, which is this column here. So 14 plus 6 plus 3 plus 9 plus 2, which is 34. And then what we're going to do is we're going to get the 256, which is all our values added together, and divide it by 34. So 256 divided by 34. And I get the answer of 7.5294 blah blah blah. And to 2 decimal places that's going to be 7.53. Now the reason it's an estimate, as I've said before, is that we don't know that all the values in the first group are 2. We are estimating them to all be 2, even though we know that some of them will be 1, some of them will be 3, but chances are it will balance out that it's roughly going to be about 2 in that group and 6 in the next group and 10 in the group after. That's where the word estimate comes. The method for doing this is how I've shown it here. I don't believe there's any other methods you can use for this. Okay, so we're given the density and we're asked for the mass, and we can work out the volume. So the first thing I'm going to do is just draw my triangle, and it's density, mass at the top, volume at the bottom. So to work out mass, I'm going to do density times the volume. Okay, so we go, first of all, have to work out the volume. And of a cuboid, it's just timesing all the dimensions together, so 33 times 22 times 7. So 33 times 22 times 7 on the calculator, and I get 5,082. And so to work out density, to work out mass even, we're going to do volume, density times volume. So density is 2.1, let's just check the units, grams per centimeters cubed, so that works. 2.1 times 5082. So 2.1 times 5082, and I get 10,672.2. Now check out the unit of mass in the density. It's grams per centimeters cubed. So that's going to be grams. Now be careful because the answer is wanted in kilograms. So I'm going to divide that by 1,000 to get it in kilograms. And it says to 2 decimal places. So it's going to be 10.67. Okay, so we're asked to find the length of the line AB. And the way of doing this is you work out how far across you go and how far up you go. And by doing that, you create a right angle triangle. So we go 2 across here, 2 jumps across. And if you don't know that that was 2, let's just do a different method. So to get this other one, 1, 2, 3 jumps up. Or you just know that it goes up to 4, down to 1, 4 take away 1 is 3. So it's a right angle triangle with sides 2 and 3, and we're looking for the third one. Now, the one opposite the right angle is going to be labelled as C. These two, it doesn't matter, I'm going to call that A and that B. We use Pythagoras' formula. So A squared plus B squared equals C squared. And A is 2, so 2 squared plus 3 squared, because B is 3, equals C squared. Let's put our lines in. So it's going to be 4 plus 9 equals C squared. 13 equals C squared. Square root both sides. And let's get my calculator. So square root of 13 is 3.6055 blah 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 equals C. So to 2 decimal places, it's 3.61. Now be careful, sometimes it will say that it's done on centimetre square grid, so you might have a units attached. If you want to put units but it doesn't say any, you can just write 3.61 units. Alright, so we're asked to draw a frequency polygon, and the only error you're going to make with this type of question is figuring out what a frequency polygon is. Now, a frequency polygon is where you put little crosses at the points, and the points lie at the group's midpoint. So we've got our first group 0 to 10, so the midpoint will be 5. Next one is 10 to 20, so that's going to be 15. Then 25, then 35, then 45. So the first one's going to be at 5, and it's going to be 6 high. It's going to be like that. Next one's 15, 22. So 22 would be about there. 25, 59. So 59 would be right up here. 25. 35, 15. A little bit lower than that, but that's fine. 45, 4. Now we're only halfway done, and my points aren't exact because the screen I'm using isn't the most precise, but it's good enough. We're only halfway done because what we need to do is join these up with straight lines, so no curves needed. And when you join them up with straight lines, do not ever join up the last 2 points. You're not actually trying to make a polygon, okay? So don't ever, when you join them up, whatever, right? Don't ever draw this line here, okay? That's not a good thing to do, so make sure you don't do that. Okay, and that's it. So midpoints, crosses, and then join them up with straight lines if you're asked for a frequency polygon. Alright, so it says that the town council is saying that over a quarter of the stores get over 30 customers. So we're going to see whether that's right. So over 30 customers would be these two groups here, so 30 to 40 and 40 to 50. So that is 19 altogether. So that's 19 out of, and let's add all the rest up. So 6 plus 22 plus 59 plus 15 plus 4, out of 106. It didn't say it in the question. So it's 19 out of 106, which as a decimal, 19 over 106 be 0.179 to 3 decimal places. So what I would say in the exam is no, because that is 17% or 17.9%. So it's less than 25%. And just write a sentence saying that yes, it's close, but it's not quite at 25%, because even rounding up to the nearest percentage, it's 18%, which is 7% lower than 25%. So just make sure you write all of the numbers in an answer that answers the question. Okay, so we're given a Venn diagram and we're asked to find the probability of, which is the P bracket, and this is not A and B. Now, loads of different ways of thinking about this. Not A is anywhere that's not in A. So it's anywhere on here that is not in A, and I'm going to shade that in with blue. B is anywhere in B, so it can be in there as well. So all of that. So the word and, or this symbol here, and, means it's got to be both in the blue zone and the red zone. So the only place that that is the case is inside this bit here. So if you, the 7 and 8 are both in A, and we can't have it in A, and the 7 over here is not in B, so those aren't counted. So the only number that is counted is the 3, so it's going to be 3 over, and we always put it over the total amount of numbers. So 7, so if I just show you, it has to be over all of the numbers added together. So 7 plus 3 is 10, 7 plus 8 is 15, so that's going to be 25. So it's going to be 3 over 25. Okay, so we're asked to write 88 as a product of its prime factors. So the first thing to do is write 88, and then we have two shoots coming from it. Now I need to find out which two numbers times together to make 88. Now a little tip, if you've got an even number, always pick 2. So 2 times 44. And whenever we get to a prime number, we always circle it, because that's finished. So 44, we can get another 2 out of that, we'll divide another 2 out of that, so 2 and 22, 2 and 11. Now 11 is also a prime number, and when you're left with just prime numbers, then you write your answer out like this. Now if you're also asked to write it in index form, that means instead of 2 times 2 times 2, you're going to write 2 to the power of 3 times 11. Now don't work that out, because that will give you 88, so 2 cubed times 11 is 88. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the two together, it's 102. So there are 102 sweets altogether. So this question says there's two triangles that are congruent. Now congruent means exactly the same shape, exactly the same size, exactly the same angles, exactly the same length. Now the important thing to notice is this angle here and this angle here are not the same. However, if you work out what this angle is, well, this is going to be 105 plus 35 and then take that away from 180. So it'd be 180, take away 35 plus 105. Now 35 plus 105 is 140, and so that's going to equal 40. So this angle down here is 40 degrees, which is the same as this angle here, and similarly this angle here is 35 degrees. So these triangles are not the same way up, and that's going to be important, because if I redraw this left hand one, I'll just do it roughly. If I redraw it the same way as we're trying to find G, so I'm going to redraw this first one. So if I redraw this first one so it's the same way up, well, this is still going to be 105 degrees. This one here is going to be 40, so I'm going to switch that around. The long one is still going to be 11 meters, and this one down here is going to be the 35 degrees. Okay, the one between the 40 degrees and the 105 degrees is 2 meters. The one between the 35 degrees and the 105 degrees is 3 meters. So therefore G, which is this one here, is going to be 3 meters. Now a really common wrong answer to this is 2 meters, because it's the same as this one. However, you can see that the triangle's not the same way around, so we've flipped it. And be careful, this is exaggerated, because in the exam the triangle, the length will look similar, but these are not drawn to scale, so don't just rely on the fact that it looks the same to assume that it is the same. In this question we're asked to compare two banks, and normally when I'm asked to compare something I just put a line down the middle of the working out, and I put one of them on the left hand side and one of them on the right hand side, and as long as it's identifiable which one is on the left and which one's on the right, you don't need to necessarily put the whole name down, but you can do. So I'm going to start with a super bank. It says we have 2.3% for the first year and 1.8% for all other years, and we're doing this for 2 years at £300. So first of all I want to work out what the multiplier is. Since this is the calculator paper, we use the multiplier method. So we start off with 100% always, and compound interest means we're gaining money, so we're going to go up by 2.3%. So that means we'll have 102.3%. So as a multiplier, what we do is we just divide that percentage by 100 to get it as a decimal into what we call a multiplier, 1.023. So if I times 300 by that, that will tell me what we have after year 1. So let's do that and calculate 300 times 1.023. And you might need to press S to D. And that is £306.90. Okay, so that's year 1, and we might as well just write year 1 somewhere. Okay, so year 2, we've got that £306.90, and we need to work out the multiplier for 1.8. So I could go through the same method as before, but actually when you start using multipliers you realise how to just go straight there. So it's going to be 1.018, but you could do 100 plus 1.8 is 101.8, and then divide that by 100. And what's that going to be? So that equals came out a bit wrong. So what's that going to be? So 306 and times 1.018. and that says it's £312, and I'm going to round this to 42. I'm going to round it to the nearest penny. Okay, so that is Superbank. That's how much we'd get. Now the Great Bank's a bit easier because it's just going to stay at 2.2. So let's work out as a multiplier. 100% plus 2.2% equals 102.2%, and then as a multiplier, that is 1.022 by dividing it by 100. So we're going to times that £300 by 1.022. So 300 times 1.022, and I get £306.60. Then I'm going to times that again by 1.022. So times 1.022, and this time I get 313.34. Ooh, actually, that would be 5 if I round it to the nearest penny. Okay, so it says, which account will give her the most money? Well, looking at that, it's going to be the Superbank. And when you're writing down an answer, make sure you write down the full name. Oh, it's not going to be Superbank, it's going to be the Great Bank. Look at that. So Great Bank Inc. And then it says by how much. So I'm going to get that by how much. Let's show the examiner what I'm doing. So I'm going to do 313.35, take away 312.42. So 313.35, take away 312.42. And I get the answer of 93p. So £0.93. Now, if you hadn't have rounded both of those, you might get a slightly different answer. And actually, technically, you shouldn't have rounded them until you got the answer. But on a question like this, where you're rounding it to the actual money she would get, they wouldn't pay her half a penny, then either answer would be correct. And in this bit here, you could have done all of this just as one bit. You could have just written 300 times 1.022 times 1.022 or times 1.022 squared. That would be absolutely fine because you'll get the same answer. Okay, with this question, the first thing to realise is that we have two similar triangles here. So we've got the smaller triangle here, and we've got the bigger triangle here. And they are mathematically similar because this angle is going to be the same as this angle because they're parallel lines, those are corresponding angles. This angle is going to be the same as this angle for the same reason, and this is a shared angle. So there are two triangles with exactly the same angles, therefore they have to be mathematically similar. And mathematically similar means all the angles are the same, but we've just multiplied all the lengths by something to get to the new triangle. So, important first step of this is to draw out the two triangles. Okay, and I'm just going to sketch them out roughly. So a small one, and we've got the big one. And then copy the length. So this is going to be 23, this is going to be 9, this is going to be 36 at the bottom here, and this one's going to be 60. Okay, now ask for the value of CE, which is this bottom length here. That's the bit we're trying to find. But I'm going to ignore that, and I'm going to work out what AC is. The reason for that is if I know AC, I can take away from 60 to work out CE, because I know the total distance is 60. Okay, to do that, I need to work out what the scale factor is. And the scale factor, all you need is a length on both of the triangles, which is corresponding, which means it's the same length, but on the two different triangles. And to do that, we do the big length. I say the same, it's not going to be the same length, but the same position on both triangles. So big length over small length. Okay, so the two I'm going to pick is obviously the bottom two. And we're going to find out what we times 9 by to get to 36. So 36 over 9. And that's obviously going to be 4. okay, because 4 times 9 is 36. Okay, so we know we times that by 4, so the scale factor is 4. Now, if we go from big to small, we times it by 4. But here, we're going from, sorry, if we go from small to big, we times it by 4. But here we're going from big to small. So instead of times by 4, we're going to divide it by 4, because it's going to get smaller, isn't it? So we're going to do 60 divided by 4, and I should really write down what I'm doing. I'm doing AC, and that's going to be 15. So we know that it's going to be 15 here for this bit, okay? But the total is 60, and we're looking for what's left over. So we're going to do CE equals the total 60, take away the bit we know that we don't want, and that's going to be 45. So the answer is 45. Okay, so in this question we're asked to enlarge shape A by scale factor -2 with the centre of enlargement 2,5. So normally we'd first of all put the centre of enlargement on, but it's already done for us. So what I need to do now is draw my ray lines, but because it's negative we know they're going to go through the centre of enlargement. So I'm going to draw my ray line. I don't need to do the bottom right one because it will essentially be the same thing. And let's do this one. Let's try and get it as perfect as we can. So it should be something like that. Okay, now the next thing to do is count how many squares we went away. So I'm going to start with the bottom left point. So we've got 1, 2, 3, 4 to get to the centre of enlargement. So if it's -2, we're going to go another 4 twice. So 1, 2, 3, 4. 1, 2, 3, 4. So we end up here. Okay. For the next one, let's do the bottom right one. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're just right on the edge there. Okay, let's do the last one. So this time I'm going to count the diagonals, and if you had a ruler you could just measure it out. So 1, 2, 3, 4 diagonals. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, and now we need to connect them all up. So let's connect them all up. And probably it will say label it B, yeah. So label it B. And always check the width of A was 2 and the width of B is 4, so that's good. The height of it is 4, and so the height of B should be 8, which it is. And it looks unusual because for an enlargement you're used to it being the same way around, but for negative enlargement it basically just flips it. Okay, so we're asked to find the nth term of the sequence. So the first thing I need to do is work out what the sequence is going up in. So 9 to 22 will be 13. 22 to 41 would be 19. It's not the same. Okay, so that will be 25. And then this will be 31. Okay, so whenever you have a sequence that's not going up by the same amount, then the next step is to work out what the differences are going up in. The difference of the differences. Well, that's 6, and this one's 6, and this one's also 6. So if the difference of the differences is always the same, then you've got yourself a quadratic sequence. And the way of dealing with that is get the difference of the differences and always halve it. Okay, so we end up with 3. Now that 3 will go before an n squared. So we know our nth term will involve 3n squared, but we don't know what the rest of it is yet. So what we do is a little table, and we write in our sequence, which is 9, 22, 41, 66, and 97. And then we write down the sequence for 3n squared, which is going to be 1 squared times 3, okay, because n is 1 for the first term. So that's going to be 3. 2 squared is 4 times 3 is 12. n is 3 for the third term, so 3 squared is 9 times 3 is 27. N is 4 for the fourth term, so 4 squared 16 times 3 is going to be 48. And then 5 squared times 3 is going to be 75. Now what we want to do is take 3n squared out of our sequence. So if I call this sequence, we're going to do our sequence and we're going to take away 3n squared from it. So basically what I'm doing is I'm going to do 9 take away 3, which is 6, 22 take away 12, which is 10, 41 take away 27, which is 14, and I'm just going to keep subtracting them. Now you might notice that we've got a linear sequence now. This linear sequence that's formed is going up in 4s. So each one is going up in 4s. And we find the nth term of this linear sequence. So we're going to have 4n, and then we're going to work out what the 0th one is. I've not left myself very much room, and that's going to be 2. So our 0th term is going to be 2, so we know it's going to be 4n plus 2. So we put this bit here with this bit here, and that gives us our nth term of this quadratic sequence. So it's 3n squared plus 4n plus 2, and that's our answer. Now you can check this out by putting in 1 and putting in 2 and putting in 3 and seeing whether you do get 9, 22 and 41, which you will do. There are quite a few different approaches for this question. One thing we can do is try and find length AD by using the cosine rule, and the other approach which I'm going to use is I'm going to work out this angle here using the sine rule, and then work out this angle here taking away from 180 degrees. Then when I've done that, then I can use the trigonometric area formula. So I'm going to work out the angle I marked first, so that is angle ADC. That's what I want to work out first. Now to do that, I'm going to call that, let's call it x, so it's a bit easier to write. So I'm going to use the sine rule, and that says that sine x over, so this is sine x, this is x here, so it's going to be over 8 equals sine 110 over 12. And the reason it has to be that way around is obviously sine matches up opposite angles and lengths, so it's going to be those two and those two. So first thing I'm going to do is just times both sides by 8. So it's going to be sine x equals 8 sine 110 over 12. And then what I'm going to do is inverse sine both sides. Scroll down a bit more. So x is going to be the inverse sine of 8 sine 110 over 12. So let's get my calculator. So inverse sine, fraction button, 8 sine 110, close the brackets, over 12, and then come out of the fraction, close the brackets. So that tells me that x is 38.789 blah blah blah. Now I want to keep the accuracy if I can, so I'm going to keep that in my calculator. And then what I'm going to do is add that to the 110 to work out what this angle here is. And I'm going to call that y. So what is this? ACD. So I'm going to tell the examiner that ACD I'm going to call as y, just to make it a bit easier. So y equals 180 take away 38.789 blah 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 plus 110. So I'm going to add 110 to that. Then I'm going to type in 180, take away the answer. So that tells me that y is 31.2104, blah, blah, blah. Okay, so I've worked out what y is, which is good, because when you have a length, then an angle, then a length all together, then you can use the trigonometric area formula. And the formula is dead easy. It just says that area equals half AB sine big C. So we know the problem is actually we've got two triangles. We've got a triangle here, and then we've got an identical triangle here, and it is identical because the diagonal of a parallelogram cuts it in half exactly. So what we also need to do is then times this by 2. Now if we notice that the half and the times 2 will cancel, so it's just going to equal AB sine C. Now I've kept that number in my calculator, so I can use it. Was A and B. A and B are going to be 8 and 12. So it's going to be 8 times 12 times sine 31.2104, blah, blah, blah. So let's quickly use the calculator before it switches off. So I'm going to press sine answer, close bracket, times 12 times 8. And it says the answer is 49.7455, blah, blah, blah. Let's have a look and see the accuracy that I need. 1 decimal place. So let's have a look. That's going to be 49.7. Now, if you didn't keep the numbers in your calculator and you rounded them, make sure you round them to 4 or 5 decimal places. So I would probably round it at least to 3 decimal places, but you normally want to go a little bit further. You might find that if you rounded it, you might get a slightly different answer to mine. Now, that's why you must show you're working out, because if you got, say, 50 rounded to the nearest decimal place, or 49.8 or something, then if you can show you're working out, if you can show that you've done all of the steps and the reason why you got slightly off was because you rounded some of your working out, you might get full marks, but you would get at least all but 1 mark for the question. Okay, so this question doesn't have any amounts in it. What you could do is put an amount in it. So we could pretend that there's 100 people in the town, and then see how long it takes for us to be beneath 43 people. That's absolutely fine method. I'm going to be doing this with multipliers though. So it says it's decreasing by 8.1%. So let's work that out as a multiplier. So we always start off with 100%. We're taking away 8.1% because it's decreasing. So we can do that on the calculator or in our head. Hopefully the answer is 91.9%. And then we need that as a multiplier. So 91.9%. Divide it by 100 to get it as a multiplier, and we get 0.919. Okay, so this is our multiplier. Whenever we times something by this number, we're decreasing it by 8.1%. Now, what we're going to do is we're going to use our calculator to work out how long it takes for that to go beneath 43%. So we're going to start off by typing in 0.919 on the calculator, but then pressing equals, and that stores it in the calculator, and that would be 1 year. We're going to times it by 0.919 again, which would give us the second year, and press equals. And because we've done it that way, if I then press equals again, it will give me the third year. Now at the moment it's 0.84, so it's nowhere near that. So I'm going to press equals again. That's the third year. 0.77, so not there yet. Press it again. 0.71. Again. 0.65. Again. 0.6. So we're getting close. Again. 0.55. again, 0.50, again, 46, so we're getting very close, and one more time, hopefully, and 0.4239, okay. So it's taken 10 years. Now, to show that, show the examiner that, I might do 0.919 to the power of 9 to show it's not enough, and then 0.919 to the power of 10. So 0.919 to the power of 9, that wasn't enough, 0.467, blah blah blah, 0.919 to the power of 10, and I show that that is enough, 296, blah blah blah. So it's going to take 10 years. Okay, so we've got a linear and a quadratic equation, and so the way of doing these is slightly different. And if you notice that each equation has this y in, now y is going to be equal in both equations, so what we do is we just get the equations here equal to each other. So we've got 2x plus 11 equals x squared minus 5x plus 4. Now we can get them equal to each other because y, if we're solving, y is exactly the same thing. So we're just getting them equal to each other because they both equal y. And then we would need to get that, move that around so that we have e equal to 0. So we're going to take away 2x both sides. So we've got 11 equals x squared minus 7x plus 4. And we're going to take away 11 both sides. So we've got equal to 0, which we need quadratics to be equal to. So was it 4 take away 11, which is going to be 7, so minus 7. Okay, so at this point we're looking at either factorizing, which I doubt is going to work, or using the quadratic formula. I think we're going to need the quadratic formula for this, so we need to remember what the quadratic formula is. So minus b plus minus square root of b squared minus 4ac over 2a. We've got a is 1, b is minus 7, and c is also minus 7. Okay, it's going to take a while. So minus b is going to be just 7, plus minus b squared, which is going to be 49, minus 4 times a, which is 1 times c. So it's going to be, and you can use your calculator for this. So it's minus 4 times minus 7, which is positive 28. It's going to be plus 28. Okay, over 2. And so 49 plus 28 is going to be 77. So we can rewrite it like this. Okay, this is where we split the two apart. We have the positive version, so 7 plus roots 77 over 2. And we have the negative part, 7 minus root 77 over 2. So the positive part, 7 plus root 77 over 2, is going to give us the answer 7.89 to 2 decimal places. Now, at this point, it's still in my calculator. Okay, I don't want to get rid of it because I need to also find out what y is. Now, it says y equals 2x plus 11. So y equals 2x plus 11, which equals 2 times this value in my calculator plus 11. So I'm going to times this by 2 plus 11. And it gives me the answer of 26.77 to 2 decimal places. And those are my answers for now. And y is 26.77. Okay, let's carry on. And I'm going to type that in again. So 7, but this time minus root 77 over 2. And it gives me the decimal answer of minus 0.89. Again to 2 decimal places. So minus 0.89. And similarly, we know that y is 2 lots of x plus 11. So I'm going to times that by 2, and I'm going to add 11. And press the decimal button, so 9.23, 9.23, and that's to 2 decimal places. So it takes a bit of time, but if you make sure you write this part here down, then you can just split it up into a positive and negative. Okay, so we've got an exponential graph. The reason we know that is because it's to the power of x, and we're given 2 points on it. So the way I'd start this question is to just look at this point here and substitute in the values. So we've got 15 equals ka, right, to the power of 1, which is just a. Then underneath it, I'm going to write this one here. So it's 135 equals ka to the power of 3. Now I'm going to think about what I do to the right hand side here to get from ka to ka cubed. Well, I'm going to times it by a squared. So I think, well, what do I do to this side? So I get my calculator and I do 135 divided by 15, which is 9. So I'm going to times it by 9. Therefore, a squared must be equal to 9, because we're timesing the left hand side by 9 and we're timesing the right hand side by a squared. So we then square root that. Now this is where it gets interesting. You actually get a positive and a negative 3, but the reason I know it's positive 3 is because if it was a negative, the actual graph would look like this. So if it's a normal exponential graph, which this is, because this passes through 1 here, then it's going to be a positive power. If it's a negative power, it means it's a fraction, and therefore it will never quite get to the y-axis. But you don't need to worry about that. If this was asked, it's normally going to be a positive, but having said that, it might not be. So anyway, I then use that a into the first equation, so 15 equals k times a, well that's going to be 3k, and then divide both sides by 3, and you get k equals 5. So k equals 5 and a equals 3, and I just need to check that. So let's do the second equation, so 5 times 3 cubed. So 5 times 3 cubed is 135, so I know I've got it right. So with this, it's an algebraic fraction, but just think of it as a normal fraction first. So just think you're doing a half plus a third. How would you do it? Well, you've got to get the bottoms the same. You've got to find a common denominator. Now the way we do these when they are algebraic expressions is just multiply both of the algebraic expressions together. So with a half plus a third, the common denominator would be 6, right? So you get that by just timesing the 2 and the 3 together. Now that doesn't always get you the best common denominator to use, but it will always work. It's just sometimes the numbers get a little bit big. So we're going to do that. Now whenever you see an expression in a fraction, always just imagine or physically draw in brackets around them, and that helps us. Now the common denominator between both of those is going to be just those 2 brackets. So what I want to do is times both of the left hand side by the right hand bracket, and times the right hand side, or yeah, you know what I mean, times the right hand side by the left hand bracket. Okay, so when I do that, I've got 3 times x plus 2 at the top, and then I've got x plus 5, x plus 2, plus 9 times x plus 5 over x. Now I'll get right to x plus 5 first, just so it looks the same. Okay, now we can just add the tops now. So I can just add the tops together, and the bottom is the same, so I'll just write it once. Now I'm going to expand the brackets at the top, so 3x plus 6 plus 9x plus 45. Okay, now I need to collect the like terms at the top, and I'm just going to put this into my answer box. Now, it might need it expanded, so I'm going to expand the bottom as well. So the bottom will be x squared plus 7x plus 10. If you don't know how to do that, see our video on expanding quadratics, or expanding quadratic equations, or expanding quadratic brackets. And let's collect the like terms at the top. So 3x plus 9x is 12x. And then 6 plus 45 is 51. And that's my final answer. Now, in the exam, it doesn't always need you to expand. I could have left the bottom with brackets around it, unless it explicitly tells you to. So I think on the website for this question, it asks you to expand all the brackets. So if the question asks you to, you do have to. Okay, there's quite a few different ways of doing this question. I'm going to do this with a tree diagram, but you don't need to use a tree diagram for this question. I just find it a lot easier. So we're going to first of all understand that when you take two tiles, you can't take two tiles. You take one and then another one. Okay, so move away from this idea of being able to take two. You can't. You take one and then you take another one. So the first pick can either be an 8, a 10, or an 11. So it's an 8, a 10, or an 11. And then the next pick, well, if you pick an 8, you can pick another 8, a 10, or an 11. If you pick a 10, you can only ever pick an 8 or an 11, because there's only one 10. And then 11, you can pick any of the three again. Okay, so with 8, you can pick another 8, 10, 11. With a 10, you can pick an 8 and 11, and that's 8, 10, and 11. Okay, now the most important thing we realise is let's work out which outcomes will end up with the second tile. Okay, and we should probably label this. This is the first tile, and this is the second tile. So which outcomes end up with her having a larger second tile? Well, this outcome here, 8 and then 10, 8 and then 11 will. If you pick a 10, then you can pick an 11, and that's larger. And if you pick an 11, you can't get a larger second tile. So there's three outcomes you can get with this, with the second tile being larger: 8 and 10, 8 and 11, and 10 and 11. Okay, next we need to work out the probabilities. Well, all of the first probabilities are going to be 1 out of 7, because there's 7 tiles. Okay, so the chance of picking 8 is 2 out of 7, because obviously there's 2 8s. 1 out of 7 for 10, and then 4 out of 7 for 11. Okay, next, if you picked an 8, then there's only 6 left, and there's 1 10. So that's going to be 1 over 6. And I'm only going to be working out the fractions of the ones I'm interested in. So 8 and then 11. So if you picked an 8, there's still 4 11s left, but there's only 6 tiles. And finally, if you pick a 10, then there are 4 11s still, and there's 6 in total. Now, we work out the probabilities by multiplying the lines we went down. So let's have a look and see what lines we're going down for the first one. So we're going 2 over 7, and then 1 over 6. So it's going to be 2 over 7 times 1 over 6, times the tops times the bottoms. Okay, next line, we're going to do same line down here, but this time we go down here. So it's going to be 2 over 7, but this times 4 over 6. So that's going to be 8 over 42. And the final line, we go down the 10, and then we go down the 11. So it's going to be 1 over 7 times 4 over 6, which is going to be 4 over 42. Now, whenever we've got multiple outcomes, and it can either be this one, or this one, or this one, we add them together. Okay, so the probability is 2 over 42 plus 8 over 42 plus 4 over 42. So 2 plus 8 is 10, plus 4 is 14, so it'd be 14 over 42. And if you cancel that down, 14 over 42, you can half top and bottom, half top and bottom, and then I think you can divide them by 7, so you get 1/3. So the answer is 1/3 chance. Okay, so this is a question on iteration, and we're given the iterative formula for a situation. Now, iteration is all about trying to find an answer, and it's a method in maths that bounces above and below constantly the correct answer, and it just gets more and more closer and closer, but it doesn't quite ever get there. It will just get more and more accurate the more times you do it. So we're looking for when to stop, and that's given here, just to 2 decimal places. So the formula is given here, and this is the only bit we need here, as well as this bit, the starting number. And in my calculator, I'm going to type in 5 minus, well, actually, no, I'm not. I'm going to press 2 and then equals. And the reason for that is it tells my calculator to use 2 if I use the answer button. Next thing I'm going to do is type in 5 minus square root answer. Now, when I press equals, the calculator will remember that the 2 is the answer and use a 2 here. Now, you might think that's a lot of effort just when I could have pressed a 2, but you'll see what the benefits are after this first run. So when I press equals, that gives me my first number, and if it comes up as a third or something on your calculator, just press S to D. So that gives me 3.585 blah blah blah. Now, the beauty of these calculators, these modern calculators, is if I press equals again, it will use the 3.585 number and put it back into the equation. So all I need to do now is just press equals, and it gives me 3.1063 blah 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 blah. Again, equals 3.2375 blah blah blah, equals 3.2006 blah blah blah, equals 3.2109 blah blah blah, equals 3.2080 blah blah blah, equals 3.2088 blah blah blah. Now, you stop when you get the first repeat of the accuracy that you're looking for. So if you look, this is the first time I've got the same answer twice, 3.208 blah blah blah. So it says it wants the solution correct to 2 decimal places. Now 3.20 is not going to be the right answer, because if I have a look, the next one is an 8. So my answer will be 3.21. Okay, to answer this question, you need to understand the sine wave. And the sine wave starts at 0 and then goes up to 1 at 90, goes back to 0 at 180, down to -1 at 270, and then back up to 0 at 360. Now, what's happening here is we're taking away 30 before we put it into sine. So at this point here, sine thinks we're at 0 because that point there is 30. So we're going to do 30 take away 30, which is 0. Sine thinks we're at 0, which it will spit out the 0 as the answer. Similarly, at this point here, it's 120. We're going to take away 30, which is 90, so sine thinks we're at 90. So all the way along here, sine thinks that we're kind of 30 to the left. And so it will be very similar to a sine wave, but it will just have moved to the right. I'm rubbish at drawing these. That was really poor because that went up too quickly there. And this is kind of a stretched out one. So we're going to go up to here, then we're going to go back down to here. Now notice that it doesn't start at 0, it starts somewhere, and I've estimated here somewhere there, and it doesn't end at 0 because it will go back to 0 at 390, because then we'll do 390 take away 30, which is 360, so it doesn't end at 0. So the rule is that if you minus something within a function, then it moves right by that amount, and it's counterintuitive. You'd think if you take away 30 it will move left 30, but it goes the other way, and hopefully I've explained why. Okay, so we've got a cubic graph here, because it goes down, then up, and then down again, and we're asked to find the equation of the graph. Now, the problem with this is the normal method is to put down 3 brackets, and any solution it gives us in the graph, we write down the opposite, the inverse sign, right? So for this one here, it would be x minus 6, because 6 take away 6 is 0, therefore that's a solution. And for this one here, it would be plus 7, because 7 take away 7 is a solution, right? Because it equals 0. But the problem we have here is we've kind of run out of solutions. And therefore the natural thing is to think, well, maybe it's a quadratic, but we can see it's not a quadratic, it is a cubic, so it needs to have 3 brackets, and not all cubics make 3 brackets, but this question will. So we've got to think, well, hang on, we actually have 2 solutions here. We've got the down solution and we've got the up solution. So that actually represents 2 solutions, not 1. And if you have a look at here, we've just got 1 solution because it just goes through once. So when it turns on the axis, it gives us 2 solutions. So there are 2 lots of x plus 7. So a bit of a unique situation, that, but it's useful to remember. The place to start with this question is just understanding that there is a triangle, and you might not know that there is a triangle for this because you might be taught it in a slightly different way. But if you were to draw a triangle for us, frequency density and class width were at the bottom and frequency at the top. Now it's a little bit misleading because actually this is proportional to the frequency density, so it's technically proportional to each other. So if you did frequency divided by class width, you might get half of what the frequency density is. So just be a little bit careful, and if they're looking for that type of question, they will give you a bar on the histogram and a value in the table that show you what you have to times them by to get to the frequency density. However, in this one we're actually asked to draw a histogram ourselves, so we don't need to worry about it. Okay, so the first thing I want to plot is our class widths on each of these, because I'll need to know what they are. So the first class width, where it's 0 to 10, so the class width is 10. The next one's 10, and be careful because actually the next one is 20 to 25, so that's only 5, that one. The next one's 10, and the last one's 15. So when I've got the class width, I can work out the frequency density. And the frequency density is the frequency, according to the triangle, divided by the class width. I want to divide these. Okay, so we've got 9 divided by 10, which will be 0.9. 1 divided by 10, which is 0.1. 6 divided by 5, well, that's 1.2. 3 divided by 10, which is 0.3. And 6 divided by 15. Well, if I've got a calculator, it's easy, but here I can divide top and bottom by 3, so that's 2 over 5. So that's 2/5, which is 0.4. Okay, now notice that the frequency density is not plotted for us, so we've got to come up with a scale. Our highest one is 1.2. So can I go up in ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. So that would be perfect. So I can go up in ones on the 5 squares. So it would be 0.2 here because they're 2 squares. 0.4, 0.6, 0.8, 1.0 or just 1, and then 1.2 at the top. Okay, now next thing I want to draw the bars. So our first bar is 0.9 high and it's 0 to 10. So we want 0.9 high, which will be here, and 0 to 10. Okay, next one is 10 to 20 and it's 0.1. So it'll be down here. I'm not going to get these exact, but with your one it's a bit easier to get exact. So 20 to 25, so we've got to be careful with this one because it's only one square across. Let's try and get it as close as I can. So that's 1.2, but it's only one square across. Okay, next one, 25 to 35 is 0.3, so that would be there. And last one is 35 to 50 and 0.4. So we go up one and then we finish that off. Excellent. Okay, so the next question says work out an estimate for the number of trees greater than 40 meters. So I want to draw a line up from 40 and we want it to go across here. So we're looking for an estimate for the amount that are in here. If you look at it, I've shaded in 2/3 of that last group. In the last group there are 6. So I want to find 2/3 of 6 because the total frequency for that bar is 6 and we're looking for 2/3 of it. Well, 1/3 of 6 is 2, so 2/3 of 6 is 4. I hope you enjoyed that video. Don't forget you can go to our website onmaths.com, which the link will come up there now, and to do the paper online, or to check out our other stuff. We've got topic busters for all of the topics that can come up. Don't forget that this is only a practice paper. We call it a prediction because what we've done is we've cut out the stuff that we feel has come up in paper 1 and 2, and so leaving a few topics that we select which ones the exam board generally goes for in paper 3 on the calculator or paper. So it's only a bit of practice. Please don't rely fully on this paper at all, and just make sure you do normal revision as well as this video. If you've liked this video, please click like. If you really like it and want to see more from us, especially in the next few days, please click subscribe. Thank you very much.